All right.
Eccentricity.
That's
and not of rich people.
No, that's a different kind of eccentricity. So eccentricity we label with an E, and it is C over A, which if you don't know what C is, then you would go about it using your nice Pythagorean relation.
Hey.
And what it is it's a way for us to kind of categorize how stretchy, yeah, for lack of a better word, an ellipse is. And so and it says over here to the side, if your E value is 0, what you actually have is a circle, because it's the same both directions. And we don't have a separate section for circles because circles are they're ellipses. Kind of like all squares are rectangles.
Right. What?
All squares are rectangles.
Since when?
Forever.
Oh, I've been living a lie.
Yes. So the closer you get for your E value to 1, the larger the difference between your major and minor axis are going to be.
Is it hot in here now all of a sudden?
I don't know. So on example 5, we're going to talk about what we were talking about a second ago about the Earth's orbit, that it's not actually a circle, it's an ellipse. Now, it may kind of be close to a circle,
right,
but it's actually an ellipse. So it has a semi-major axis. A equals 149.598 gigameters, which is like a cool unit.
A million meters?
It could be. How much is a gigabyte?
A million bytes?
Then it has to be a million meters.
It's a million megabytes. I don't know.
I don't know either. And an eccentricity of E equals this number.
So he's not very eccentric.
No, he's very close to a circle.
Yeah.
So, and the closer to a circle you are, the closer in your foci are. So our foci are actually really close to the center.
Yeah, they're not far apart at all.
Yeah, so calculate and interpret B and C. Well, if we know what A is and we know what E is, we can find C using this formula, and then once we have C, we'll use the Pythagorean relation to find B.
Sounds great.
So 0.0167 is E. We want to find C over 149.598. Oh, do you want a calculator or?
I got a calculator right here. So that's going to be 0.
So we'd multiply those together to get C.
Times 149. I got that number right there.
2.498 gigameters. Thank you. I got it. Thanks. Okay.
Right.
So that's C. Now let's interpret what C is. What is C normally?
That C is the distance from the center to the focal point.
Ooh. The distance from.
So the center of
the center of the orbit.
Of the orbit, yeah. Which means that.
To each foci.
Right.
So we just said that, it's circular. It's pretty circular, so that means that it's the foci are really close to the center, but very close to the center. It's still 2.498 gigameters.
I don't even know what you just said right now,
pretty far.
I have a hard time talking about 2.498 million miles. So
yeah, that's quite a situation to have. So then our B, we're going to use our Pythagorean relation for.
Well, now we have A and C, so.
Yeah, so our Pythagorean relation was a squared minus b squared equals c squared.
Right.
So 2.498 squared equals a, which was 149.598 squared minus b squared.
Oh boy, that's a lot of stuff going on there.
So, I mean, you're
basically trading b squared in the 2.498 is what you're going to do.
Yeah, you're
and then take a square root.
You want to.
Well, there it is right there. I couldn't even punch that in, but we happen to have it.
So after square rooting, you should end up, and I could have just plugged it into this formula as well. C equals square root of a squared minus b squared, but we still would have had to solve. So B is 149.577 gigameters.
Oh.
And so what is B telling us?
B is how far from the center of the orbit we go to get to that edge. The upper or lower edge.
Okay, so
it's the semi-major.
The distance, isn't it the distance to the closest point in the orbit?
That's probably a good thing to say, yeah. I like how you said that.
And speaking of which, what were those words you were saying earlier so that we can define them really quick? These may come up at some point. So
there is perihelion.
Perihelion, is that right?
Yeah.
Okay.
I'm not sure how
A perihelion is something to that effect. Is
closest
what you should see.
point to the focal.
Closest point to the focal?
To the focus, yeah. Closest point to the focus.
To a focus.
A particular single focus. So we're talking about just one focus for the whole thing.
One or the other focus?
One or the other.
And then
aphelion, APH, and then the elion. These sound Latin.
It could be.
Do we need to go find Miss Turner and get some Latin?
No, let's just keep going.
So
that's the farthest.
So if we talk about the same focal point, now we're not switching focal points, but if we talk about the same focal point, now this is the point furthest from.
Okay. So closest point, the distance to the closest point in the orbit, this was from the center.
Yeah, that one's from center.
Because we're talking about
right.
B.
And these are from focus.
Okay, so that may come up in a problem or two, so now you know what the perihelion and aphelion are.
Exactly.